Find the elevation at point D in feet. In this problem, a crest vertical curve extends from point A to point C and has a length of 600 feet. The grades of line segments AB and BC measure out to be positive 0.60% and negative 1.00%, respectively. Also, the station and elevation of point A are provided. The problem asks to find the elevation of point D, which is located at the maximum elevation along curve AC. The equation for a point on a vertical curve is y equals r over 2 times x squared plus g1 times x plus the elevation at the beginning of the vertical curve. In this equation, y refers to the elevation of a point on the curve. So for this problem, we'll rename this variable to be the elevation of point D. The elevation at the beginning of the vertical curve is the same as the elevation of point A. Variable g1 refers to the grade of the tangent at the beginning of the vertical curve, which in this case refers to the grade of line segment AB. Variable r refers to the rate change in the slope in units of percent per station, where r equals g2 minus g1 all divided by L, where g2 equals the grade of the line segment tangent to a point at the end of the curve, which for this problem is the grade of line segment BC, or negative 1.00%. Similarly, variable g1 refers to the grade of the line segment tangent to a point at the beginning of the vertical curve, which in this case is the grade of line segment AB, positive 0.60%. The variable L refers to the length of the curve, which is 600 feet or 6 stations. This makes the rate change of slope equal to negative 0.267% per station. Now, the only remaining unknown variable on the right-hand side of the equation is x. X refers to the distance from the beginning of the curve to the point of interest, which is point D. Since the problem states that point D is at the maximum elevation on the curve, we know that x equals negative b divided by 2 times a. In this quadratic equation, b equals g(ab), or positive 0.60%. The variable a equals r divided by 2, where r equals negative 0.267% grade change per station. After substituting in the appropriate variables, x equals 2 plus 25 stations. Plugging this value into our equation for the elevation at point D, as well as our values for variables r, g, ab, and the elevation at point A, the elevation at point D computes to 318.87 feet. When reviewing the possible solutions, the answer is B.